Hi guys, welcome back to our lesson. So we are still looking at the proofs of parallelograms, right? So mainly what this is all about is to try and look at what are the properties of a palm that I can try and apply in trying to prove that any quadrilateral that I'm given at any point is actually a parallelogram, right? But that is mainly because of what makes a parallelogram to be a parallelogram. Not just because you know that this is a quadrilateral and it looks like it is a parallelogram, then you will say it is a parallelogram. Funny thing is, some people do that. They look at it and say, yes, it is a parallelogram. They erase it because it looks like it. Please don't even try that, right? You always need to work out and show me your proof why you think it is a parallelogram. So let's look at some more questions that we're going to try and solve. That these ones are a bit more complex because now there's more additional stuff that you need to do and there's more implicit information that you need to be able to see without you being told. So let's look at the question. So this says the angle bisectors of L and N, right? Angle N and angle N of parallelogram KLMN meet diagonal KM respectively in O and P, right? So in simple terms, they are saying the angle bisector of L meets O, right? And the angle bisector of meets the line at O, and the angle bisector of N meets the line at P. That's what the word respectively means, right? So this is number one, so this will be number one. This is number two, this will be number two. So the word respectively just does not mean just respect or anything like that. It just tells you to follow the same order that we gave you in the previous statement. Now we are required to prove that OLPN, right? So let me just show you. It will be something like this. So they actually want us to construct a quadrilateral there, which is going to be OLPN, and we need to prove that this is a parallelogram. Now, what do I know here, right? I know, number one, that I have an angle bisector making N1 to be equal to N2, right? And also L1 to be equals to L2, right? I know this. I also know that my L1 will be equals to, I don't have anything equals to L1. I actually have K1, that's what I wanted to talk about, is equals to M2. And that's because of alternate angles that we have. And also this one here will be equals to the angle that it makes with the same transversal with the parallel line, right? So which is M1. So these are the things that I know so far. Now I'm going to try and use all of this that I've just added here to prove that this shape in the middle is a parallelogram. So let's actually look at it. So firstly, I'm going to show you the nicer version of my diagram so that you can see these arrangements and these relationships based on what we are given, right? So I know K1 is equals to M2. I said that's alternate angles. I know K2 is equals to M1. That's also alternate angles. And then my red there will be the angle bisectors. All right, so to apply all of this to try and prove that the middle quadrilateral is actually a parallelogram, we are firstly going to focus on this triangle here, and then we are also going to focus on that triangle there, right? So I'm just going to write them down. So inner triangle, KOL, and triangle NMP, N for no one and M for money and P there, right? So I must prove that in this triangle this side and that side are equal. If I can do that, then I will be one step closer to also proving that this side is equals to that side, right? So let's quickly look at that. So I know that in these two triangles, my K1 is equals to my M2, and this is because of alternate angles, and this is because KL is parallel to NM. And then from there, I also know that my L1 will be equals to my N2, right? Remember why this is the case, because of the fact that there's a bisection of the angle, right? Remember, the opposite angles of a palm are equal to each other. So if they are bisected, it means they are both cut into two equal parts, right? Bisection of opposite angles of a palm, right? And then I need one more thing, and that one more thing needs to be a side, because I can't use angle. And that side will be none other than KL being equals to NM. And this will be because its opposite sides of a palm are equal, right? Opposite sides of a palm are equal. Please remember, guys, as I'm using this palm, it's actually short for parallelogram, right? I just don't want to write the whole. And mathematically, by the way, this is how we do write it. So as a result, I will then say that triangle KOL is congruent to triangle. Now K goes with M, so I have it there, and then my L goes with N, so it will be the N there at the end, and then P, so MPN. So because of that, then I will claim that OL is equals to NP, right? And this will be because from congruency. And then now I have killed one bird, right? This one. Guys, don't kill birds. I'm just joking when I say killed one bird. So I have actually solved that OL is equals to NP. Now I want to show that ON is now equals to LP, right, for leopard. If I can do that also, still using the concept of congruence, then I would actually know that these two shapes are, that shape is a parallelogram. Now, I'm just going to show you on the diagram, right, because then you will be able to see it. So it means this angle is going to be that angle, equals to that angle, right, because of properties of congruent triangles. And if that is the case, then I also know that this angle here will be equals to that angle there, right? And my reason for that will be adjacent angles on a straight line. I know that this is a common side, right? And then also the last thing that I know will be what? I will know that this side has been proven to be equals to that side. So now I have side, angle, side. So I'm going to write it down for you to be able to see it. So the first thing I said was O2 is equals to P1, right? So this is going to be O2 is equals to P1, and this will be adjacent angles on a straight line, angles on a straight line. And then from there, what else do I know? I know that OP is a common side. So OP is common. OP is common. And then the last thing that we want is to say OL is equals to NP. So OL is equals to NP, right? And this was proven above, right? So this is proven. And then as a result, I will then say that triangle, let's quickly look at it, triangle OPL. Triangle OPL is congruent to triangle our O we said goes with P, and we said our O goes with P, and that means the L will go with the N, and then the P will go with the P with the O, right? So it will be the P will go with the O this side, and then the L will go with the N. And then from there, this is because of side angle side. Then I will then claim that my last thing that I wanted to actually do because of this was to say ON is equals to LP. ON is equals to OP, right? Is it OP or LP? ON is equals to LP, not OP, LP. Now, my reason for this will be again from congruency, Then as a result, I then conclude my O, let's just go back, OLPN. OLPN is a PAM, right? My reason for this will be both pairs of opposite sides are equal, and then that's where you will end it. So I know this is a lot of work, guys. That's why I said to you, this is a more complex one that we're going to do. But congruency seems to be the very useful tool that we're going to use to prove equality in terms of shapes that we have, because congruency is easier to prove than any other property of shapes in mathematics, especially geometry. So just make sure that you are clear on that, right? So you first use congruency as a rule, and then as a tool, and then from congruency you can claim that certain things are equal, and then as a result you can claim that the shape you want is a parallelogram, given that you have proven one of the 5 options that I've given you when we started this. So guys, I hope that is very clear and you can understand this. I know it's a lot of O's and L's and N's there, but I believe that as I was writing it down, you were also writing it down and you managed to understand what we did. If not, please do some research from your textbooks, from your internet, so that you can understand it better. But for now, I want us to take a quick ad break, then we're gonna do one more question that is going to try and apply these rules that we've been talking about. Please stay tuned, I'll be back just now.